everyone. Hey, I'm Philo, and for our first research presentation of the semester, I'm going to be talking about how I backdoored IPTables. First, a bit about me. I'm Philomena Gray. Philo, for short, I used to go by Robert, and in my 4th year, and I'm selected ops lead and president of NextHop. So let's take a look at the Linux networking stack. This is a bit of a spaghetti nightmare mess, and let's just talk about IPTables first. So IPTables is Linux's built-in firewall that pretty much any packet heading to a Linux system has to go through in order to actually get to an application. So pretty much anything that isn't using raw sockets goes through this. And yeah, so it, of course, is a important security measure. Sure. And here's a diagram of just IPTables and user space, because that's what we actually care about. TCP dump gets packets before they go through IPTables through a mechanism called the Berkeley packet filter, which would be a great topic for another research presentation. Then packets get sent into IPTables. They go through raw, NAT, mangle, filter, and security tables. Of these, filter is the most commonly used. And then if it passes all of these, then it gets sent to the application. You'll see later, these all share logic and are incredibly easy to mess with. Well, not incredibly. They share logic, which makes them easier to mess with than they could be. So, so this is the evil bit. It's an unused bit in the IPv4 header that was the subject of the April Fool's RFC in 2003. If your packet contains evil intent, so if it's hacking, or if it's so all packets Emmanuel sends, and because he's the red teamer, have to have this bit set, and firewalls are supposed to drop this bit. Obviously, no one actually follows this because it's just a joke. But the bit's there; it's not being used for anything else. So, see how I used it in a minute. So in order to generate it, you either have to use raw sockets to produce your own IP packets, or you have to modify the Linux kernel itself. Because for most normal applications, the whole TCP connection is handled by the OS, by the kernel. So by adding one line that adds that sets that bit, then all TCP packets that get sent from that machine will have the evil bit set. Or of course, you can also use Scapy, Scapy is a Python tool for building up packets. It's way easier than using the C libraries for raw sockets. Then comes putting that and IPTables together. I initially tried to add another table to that sequence we saw earlier, but there's no clean way to make a table bypass all others. Gave up on that. However, I found the IPT_do table function, which all the other tables call, and just made it, as soon as it reads the IP header, checks if the evil bit is set, and then if it is, just accept the packet, and that's just running in all the tables. It will, no matter what the rules are set to. Of course, to modify this, you have to recompile the Linux kernel. Most of what's considered key functionality on Linux is actually in a kernel module, which those can be reloaded at runtime, but it turns off certain debugging features if you load them that way. So I decided to compile the entire kernel, which entails messing around in this kconfig menu, setting things, waiting for it to compile, running out of disk space on my VM, compiling it again, adjusting my VM, compiling it again, and it worked. So now, do a demo. Okay. Okay, so we have. Yeah, no, I just paused my VM. Yeah. Okay. I should have unpaused this before the presentation.
I can show both VMs, but you need two, right?
Yeah. Okay, so so I have these two VMs, which have the kernel modules that I modified on them. They're set to make every TCP packet they send have the evil bit, and make every packet with the evil bit set pass through the firewall. And then this is just a normal Kali VM. So let's set some firewall rules on VM2. Let's just, drop all packets outbound and inbound. Then let's try and SSH to it from this VM. Okay. And as you can see, it just sits there and times out. However, if I SSH from this one, see, it just asked me for a password. And I'm in, you see. And you can even, you can even see that the SSH to it, even though the firewall is supposed to be blocking everything. Yeah. And any questions? Yes, Tenchi.
Can you show the kernel modules that are loaded on both?
Oh, yeah, right, of course. Yeah, as you can see, it has IPTable evil, which isn't normally there. Even though it isn't using IPTable evil as its table, I still have it loaded, if only just to tell that whether I've loaded everything correctly. Yes, AT.
Do blue teamers / red teamers have to worry about this for IRSec?
Depends on how successful Emmanuel is at pressuring me into doing it. Yeah.
So since we have a lot of new people here, can you run through an attack scenario about how you would actually go from start to finish of putting this on a machine or using this in, say from a red team perspective?
Okay, so
an attack narrative.
yeah, so this would be used to really maintain access to a box that you've already gained complete control of, because you need to be root to load kernel modules. But this just makes their, you just use it to make their to be able to get through their firewalls if they set them up, which is not necessary, which not everyone does as an IRSec. Sometimes there are bigger fires to fight.
Sure. Yep. So it's a method of persistence.
Yeah.
So it's similar to like an IP tunnel?
Beat that?
Similar to an IP tunnel in that sense then?
I-
It's trying to maintain access.
I guess, yeah, in that both can be used as persistence methods, yeah. Yeah, Evan?
So from an IR point of view, let's say you have port 22 block coming from outside RFC 1918, but with this module that's allowed through, what does detection look like? So
Yeah,
how-
so
how
it'll-
would from the incident response side.
So
how
you
would-
you will see in your SSH server logs connections from those external IPs.
Okay,
And
so-
also, if you're running TCP dump, the packets will show up in there.
Okay, so it still shows up by
Yeah.
common detection methods.
Yeah, I didn't really put much effort into hiding it.
Okay, so there's no
And-
hiding capability. So
and, like-
all standard detection still.
Yeah, and
works there.
and also it even still taints the kernel. Yeah, you see, yeah, because on a Linux system, if you load modules that weren't compiled at the same time as your kernel that disables a bunch of debugging features, and that's called kernel tainting. Of course, you can just recompile the whole thing and bypass that. I'm probably going to be doing I'm going to be doing more research into that, but yeah, at present, this does taint the kernel. It's not well hidden. Yes, Tenchi.
So, from somebody who doesn't know much Linux, in basic terms, what is a kernel?
So the kernel is the core of the Linux operating system. It's what sits between all the other applications and the hardware. And it's full of drivers, and it contains the network stack and all of that kind of stuff. Okay.